Hi, I'm Rich with insideHPC. We're here at the Dell HPC Community Group Meeting in Austin, Texas. And today I'm here with Thomas Lippert from Jülich Supercomputing Centre. How are you doing today, sir?
Fine, thanks.
Well, thanks for coming on. I know you don't do a lot of interviews, but why don't you start from the beginning? Tell us, what is your day job at the Supercomputing Centre?
Actually, I'm leading the Jülich Supercomputing Centre. So my day job is to let people do their job, yeah, primarily. But actually, I'm a physicist by training, so a theoretical physicist, and still do a lot of, let's say, science. Then doing activities in computer science, building cluster computers, building new, probably exciting, let's say, technologies and architectures. That's my day job.
Well, hey, I saw your presentation today. Could you summarize kind of the high points? I mean, it sounds like there's some really exciting things coming down the road with Dell and what you guys are doing at Jülich.
Yeah, so for about 6 years, we are doing research in the field of accelerating cluster computers. But not just local accelerators, we try to get all the accelerating chips into one machine and try to connect it to the cluster. So we have a, let's say, very strong connection between the cluster and the other cluster, which we call booster. Yeah? So the accelerator we call booster. And then we try to get, let's say, the performance critical parts of a code that we have on the cluster to be executed on the booster. So we have, of course, to take care that the right processors are spawned on the booster and that the data are just, let's say, transferred from the cluster to the booster and from the booster to the cluster if they are computed. Yeah? That's the way we see this. And so we have made this research together with let's say Intel, together with many other partners, primarily with company Partec, which is Munich-based, and with the software Parastation, which allows us to do all of these, how can I say, manipulations between both systems.
You said something very interesting I want to ask you about. As we move to Exascale, you said this will not be a general purpose machine if we do it right. Did I get that right? Is that what you're...
Yeah, I said moving to Exascale is a process. Yeah? Yes. So let's say for some fields it will be faster and for other fields it will be slower. As it's moving to Petaflop. I see a lot of fields today that cannot execute on Petaflop machines. Yeah? And it will take much more time. So what we have in mind is that moving to Exascale, first of all, will try to get those problems that need a lot of compute time to be running on systems that are well suited for that. And this is one of the, let's say, cornerstones of our approach.
Well, last question, you know, there's like 300 some people here, a lot of users. What is the importance of that people component? Because supercomputing just isn't machines, it's people that know how to use them and create them and make them go fast, isn't it?
Yeah, it's very clear that we would, of course, do a wrong job if we wouldn't have the right users with us. So we are, in Jülich, we are completely user-driven. We are only looking at what is really needed, what is our portfolio that we have to serve. Yeah? And in this manner, we are, let's say, trying to choose our compute technology and to create our compute technology. Actually, we are a research center and not just a supercomputing center. So buying supercomputers would not be the right job for us. We are asked to do research on supercomputers and then, let's say, make them more fit than they would be without being, let's say, improved by our type of research. That's it.
Well, it sounds like you got a busy week here, and I want to thank you for talking to us today from insideHPC.
It was a pleasure. Thank you very much.
Thank you.